This is part 5 of a 1 hour and 40 minute recorded Twitch stream from the 16th of April 2020, where we discuss the various MPLS VPN building blocks from a design perspective. In this session, we will bring all the previous steps together to validate the MPLS VPN design and end-to-end connectivity across VRFs. We hope you enjoy the video, and if you do, please let us know by providing a like, comment, or telling anyone you know who may be interested. Thank you. There you go. So BGP, VPN v4, unicast, all summary, which shows that we have two neighbours which are up to the PE, 5.5.5.1 and 55's.1, which is PE1. If we go back here and do show IPv4 interface brief. So we've got 5.5.5.1 and 55.55.55.1. We should get, so you see there that we're peering to 5.5.5.5 and 55.5, which is the addresses that are here on this router. Let me just see then. So when we were looking at the configurations on CE or the CSR5 on the left hand side at the top, we were advertising a route in VRFB. So if I do show route VRFB, hopefully I should be receiving that, which I am. So I'm receiving that, and if I do a ping VRFB 100.55.55.55, I get a successful ping. So that's at the first hop. So if you were like troubleshooting the network, you can see that you would be sending it over, you're getting it sent in its own VRF, and then what we need to do next is, or what we would do to the next place that this advertises it to is the route reflector. So XRV3 is the next place that it would receive it from the CE to the PE via IPv4 unicast and VRF8, and then it would add the route distinguisher, route targets and all that, and it would advertise it up to the route reflector. It would only use XRV2 as a transport. Once it hits the route reflector, it would then reflect the route down to XRV4, and effectively, if CSR7 was in VRFB, that's how it would be able to ping end to end. Just one thing to note, that you would not go from CSR7 to XRV4 and then to the route reflector. With VPN v4, the route reflectors are not in the data plane path, so by default. In IPv4 it's different, but in VPN v4 it's not in the data plane. So if I go, if I log into this Cisco, this is the route reflector, and I go show BGP VPN v4 unicast. You can see here that so this is the command here. You can see down here, if you look closely, if you were troubleshooting the network, so you know how I said that there's no VRFs on the route reflector. However, there is VPN routes, right? So the customer VPN routes are stored on the route reflector, and you see this one here is 100.55.55.55, but it doesn't say VRFB. It says route distinguisher 2.2, because if I do show VRF on this, there's no VRFs. So what I would need to do is go to a PE that I knew it was connected to if I wanted to troubleshoot this route, and I would say show BGP VPN v4 unicast. What's the route? It's 100.55.55.55. Anyway, there's a command that basically I would say show BGP VPN v4, and then specify the route distinguisher, and that's how you would tie it together. So you would see that the route distinguisher 2.2 ties to the VRFB, and that's how you tie them together in order to troubleshoot a routing problem. Now let me just see, I don't know if I got this far in the configuration because I only had a couple hours to put all this together. I started doing this at 6 o'clock UK time, and the session built this whole lab from scratch, and it's not documented, I just made it up off the top of my head. So if I do show BGP v4 unicast, oh, I'm getting the route. So let me see if I can do ping VRFB 100.55.55.55. Don't know if I've got a source address. This is yeah, I might need to, because it's probably sourcing it from the, yeah, I don't. Right, let me fix this quickly. Conf t int loop back. What are we on? 44. VRFB IPv4 address 44. Well, I'll say 100.44.44.44/32, and then I go into router BGP1, which is the MPLS core, and I go VRFB address family IPv4 unicast network 100.44.44.44/32. I think it'll work. Hopefully that'll come match. Show config inheritance. Right, route distinguisher. Right. Right, let's try that. That seemed to work. So if I do show, so I'm just doing this on the fly. Show route VRFB. Yeah. So you see here now I've advertised. I advertised the route from PE4 on the right hand side, or XRV4 on the right hand side, and now I'm on XRV1 and I'm receiving that. The reason that I couldn't ping before, I think, if I try it now, ping VRFB 100.55.55.55 source 100.44.44.44, you can see I can now ping. And if I do a trace route VRFB 100.55.55.55 source 100.44.44.44. So what I'm doing here is I'm doing a trace route from XRV4 through the P node, through the PE node, and then down to the CE device on the left, and it will show you that I don't go via the route reflector. So I don't think I do anyway. 1010. Aye. So yeah, there's 3 hops. 1, 2, 3. and none of those are the root reflector. All we're doing is learning the root from the root reflector, and that's why it can stay out of path. And that loops back round to, you know, the design aspect. With MPLS building blocks, root reflectors do not need to be, and they shouldn't really be, in the data plane path. So I think on that note, so I'm just going to go and recap what we talked about, and hopefully it makes sense. So the objective was to cover the building blocks of MPLS on this session, and we talked about the various different parts. So the various different parts of MPLS are as you see on the left hand side, and we talked through that from a design perspective. One thing that sort of came up was, what about layer 2 design? But my feedback on that is layer 2 design, unless you're talking about layer 2 VPNs, has minimal impact in MPLS core networks, other than if you have to like aggregate links and layer 2 port channels or provide services via layer 2 trunks and things like that. But that's really a whole different discussion and a wider design on a larger network. We talked about transport and documenting the physical connectivity. We talked about defining loopbacks and the importance of defining loopbacks in an MPLS core network. We also talked about advertising those loopbacks into an IGP, a link state IGP. We never really covered IS to IS, but it's the same concept as OSPF. And the configuration, after you do it a few times and you learn about the specific differences, it's not that as daunting as it might seem to learn IS to IS. So yeah, maybe one for a future day, but it's the same concept in regards to MPLS building blocks. Once we've advertised the loopbacks into OSPF, we then are able to use them to facilitate label switching via LDP and building sessions between nodes and LDP relationships. We then, once we have LDP up, and label switch paths up, we can then deliver VPN v4 and VPN v6 unicast within the core of the network. So where you see the blue outline, that's where we define VPN v4 and VPN v6. After we define VPN v4 and VPN v6, we build out VRFs. VRFs are only configured on the PE nodes of an MPLS network. They are not configured on a P node, and if a VRF is configured on a P node, then it becomes a P/PE or just a PE. After we build the VRFs, we are then in a position on the PEs to peer to the customer edge routers. So that's the routers on the left hand side and the right hand side just out of shot that I've highlighted in red, just there. Those are the customer, and then we can deliver multiple services with the use of VRFs, and this is where layer 2 might come into the equation. If you need to create like a layer 2 or a layer 3 SVI or something, a bridge domain, a BDI, bridge domain interface, or something like that on your PE node, and then a similar thing on the CE that you might need to configure in the opposite direction. And that allows us to deliver multiple VRFs, which then gives us the ability to, for example, give us multi-service being handed over to the customer on a single box. The example that we gave was the green line being customer A, the purple line being customer B, and that's what we demonstrated in the configuration. The red line could be, for example, SIP, and the bottom line here could, for example, be an internet service, all delivered from the same service provider. So I think that kind of covers it, and we'll wrap the session up there for today. I'd like to thank you very much for your patience, your perseverance, and your attention, and I wish you a pleasant evening or the rest of the day wherever you are located. Thank you very much. Bye bye. This concludes the fifth and final part of MPLS VPN building blocks. We would like to thank you for watching this video series, and please remember to subscribe to our channel if you are interested in more network design content. You can also visit our website to explore the consultancy and training services that we deliver globally, or contact us on social media or via email if we can assist you with a networking or security project.